Hello everyone. So today we will look into the topic anthropometry. Hope some of you might have already come up with the word anthropometry. So let's see what it is. Anthropometry is nothing but the measurement of dimensions, and it also involves certain physical characteristics of the body, such as it can be volume, center of gravity, inertial properties, and mass of the body. So basically, you should understand that anthropometry is nothing but the measurement of dimensions related to our body. So these dimensions are mainly can be classified into two, that is static dimension and dynamic dimension. Static, as you already know, it means fixed, and dynamic is functional. So static measurements will be taken when the body is at rest or not in any motion, and dynamic means the measurement of the body dimensions when we are doing some work or any functions or any activities. That is why it is not also called functional body measurement or functional anthropometric data. So we will look into each of these in detail, that is static and dynamic. First we will look into static dimensions. So static dimension, as a word, as I just mentioned, and as the word indicates, that the measurements which are taken when the body is in a fixed or a static position. Mainly they involve skeletal dimensions, that is skeletal dimensions means centers of the joints, such as between elbow and the wrist, or dimensions like the dimensions such as head circumference, etc. And the usually body measurements vary as a function of age, sex, and for different ethnic populations. Generally, we can see that as our age goes on, our body dimension increases, and then it remains constant. And towards our old age, there will be a slight decline. This is also stated by Strout in 1981. So he tells that in connection with age, the stature and related dimensions, that is length and heights, generally increase until the late teens or early 20s, which is our growth time, and remain relatively constant throughout the early adulthood, and decline from early to the middle adulthood into the old age. So that as a general we can tell this, but as an extra information, or as an exception, if you clearly observe the length of our ears, and it is found that the length of the ears continue to grow throughout the life. Now this is a picture showing the different body dimensions, that is diagram of structural static body features for which data are provided for US civilian population in the age group of 20 to 60 years of age. So you can see the chest depth, stature height, eye height, etc., and few numbers are given in the bracket. Okay, that is a survey was conducted among the US civilian population, and a general dimension for an average individual has been laid down, and it is shown in the next slide. It shows a table. So table selected body dimensions and weight of US adult civilian. So as per that number, it is being laid down here, and so this is the body dimension, different body dimensions, and the first column is dimension in inches, and second one is dimension in centimeters. This is cm, not em, and this data is taken for both male and female also. So you will see that three different values are given both in inches and in centimeters, that is the 5th, 50th, and the 95th percentile. Now what is the significance or relevance of these three dimensions? For that you must understand this curve, or this inverted bell curve. For example, if you take the height of of students in a class and you plot it in a graph, you get a shape like this. Most of them will be in this average region, that is average. Most of the height will be in this average region, and a few, very few, will be very shorter, which is shown in this region, and very few will be taller, that is shown by the this region. So the importance of this graph in anthropometric data is that when you design a thing, for example, maybe it's a seat, or it is a position of a switch, you should consider this fifth, 50th, and 95th percentile significance. That is, you should first of all decide whether you are going to design for this fifth percentage of population, or you are taking into consideration of this major group, or the average group of people, that is the 50th percentile, or you are doing it for the 95th percentile. So that is where this important graph comes into picture, and that is why you are given three different values here. For example, if you take the elbow height and you're taking considering male, you can either have 39.4, that is the fifth percentile value, and the 50th percentile is 43.3 inches, and the 95th percentile is 46.9 inches. So if you are designing a cabin, you are considering elbow height, you can fix whether you want to go for fifth percentile, 50th percentile, or 95th percentile. To make you understand this better, let's consider an example. So in this slide, an anthropometric constraints are explained, or rather, this is an example of how to use this 50th and 95th percentile. So, as an example, consider the following design scenarios and discuss why the particular range has been used. For example, we are designing a car dashboard. So, car dashboard in the sense means that even the shortest person should be able to reach all the parts of the, or the main important parts of the dashboard. So in that context, we should always go for fifth percentile measurements. Why? Because the smaller people can reach the instruments easily. So the design of a dashboard where reach of various functions, maybe it is a music player, or or a gear lever, or any such functional keys, etc., are very important. The reach of those locations are important. There we always prefer fifth percentile data. Now if you are designing an aircraft seat, or another, if you take another example as designing the entrance for a doorway of a classroom, so in that case you are expecting that the most taller person also should be able to freely fit into that classroom or that seat. So here 95th percentile data should be used, so that the larger people can sit in the seat comfortably, or if it is in the case of a classroom entrance or a doorway to the classroom, the tallest person can also enter freely. So hope you have understood the significance of anthropometric constraints. Now we come to the second anthropometric data, that is the dynamic or functional dimension. Now here the dimensions are taken under conditions in which body is engaged in some physical activity. For example, it can be lifting an object, it can be driving a car, etc. The practical limit of arm reach, for example, is not the sole consequence of arm length. The limit is also affected by shoulder movement, partial trunk rotation, possible bending of the back, and the function to be performed by the hand. So all these are the factors upon which dynamic dimensions depend. Now this slide shows a forklift operation So this three figure shows the three views of the operator. That is the frontal view, the side view, and the top view. So from this three diagrams, we can find out the dimensions or the dynamic dimensions of the operator of the forklift truck operator. So although there is no systematic procedure for translating the static anthropometric data into dynamic measurements, there are some thumb rules that should be considered. First one is height, which involves stature, high, shoulder, or hip. This should be reduced by 3%. That is, if you're having the data of, for example, eye or shoulder in static condition, and converting the data into dynamic measurement, it should be reduced by 3%. Similarly, elbow height, there is no change, or if it is elevated at work, it should be increased by 5%. Similarly, knee or popliteal height, popliteal means area behind the knee, there should be no change except at high heel shoes and forward and lateral reaches. These are all the general thumb rules for converting static data into dynamic data. Now coming to an important topic, that is principles in the application of anthropometric data. Mainly there are three general principles for applying the anthropometric data to specific design problem, and each one applies to three different type of situation. We will look into what are these three types. So first one is design for the extreme individuals. This second one is designing for adjustable range. Third one is designing for the average. We will look into each one of these in detail. So first one is design for extreme individuals. So from the topic itself, in this design criteria, one is trying to accommodate all, that is the population, total population as a whole. The limiting factor can dictate either a maximum or minimum value of the population variable or characteristic in question. If you are designing for the maximum population value, appropriate strategy if a given maximum value of some design feature should accommodate all. For example, to understand it better, consider the example of heights of doorways or sizes of escape hatches or manholes, etc. In this case, you are expecting the taller person or the person with the maximum dimension to pass through that doorway or the manhole. So you should be designing with the maximum population value. And just reverse is the case with designing for minimum population value. Appropriate strategy as a given minimum low value of some design features as to accommodate all. So low value of design feature should be used here. So as an example, you can think of distance of the control button from the operator and the force required to operate that control. So if that control is to be smoothly operated, the force required for operation of that button or the control switch must be minimum. So these are the case where minimum value should be used. That is, only if the minimum value is used, you can press that button with the minimum effort. Similar is the distance to a control button. If the operator is sitting somewhere and that switch is very nearby, it will be easy for him. So there also the minimum value will come into play. So this is the design for extreme individuals. Extreme individuals will have either two possibilities, that is designing for maximum population value or designing for the minimum population value. Now the second principle is designing for adjustable range. In this principle, consider the example of design of automobile seats or office chairs, desk height, or footrest, etc. So in all these examples, you might have noticed that there is always a provision for increasing or decreasing the height, or for example, in the case of steering wheel designs, nowadays we have adjustments for height as well as for the reach of the steering wheels. So in all these cases, you are fixing a range, and this and and the dimensions can be adjusted within this range. So in the design of such equipment, it frequently is the practice to provide adjustments to cover the range from 55th percentile female to 95th percentile male of the relevant population characteristics. The best example is that of an office chair. So nowadays most of the office chairs can be height adjustable. So in that we fix the range from 5th percentile female. So 5th percentile itself is the lowest range, and when we consider the female value of that 5th percentile female value, that is the lowest among all. So from that lowest range we consider up to the 95th percentile, and that to 95th percentile male value. So that is the range. It is a very large range, so that any population which is coming under this range can easily use the equipment that is needed. The use of such a range is especially relevant if there could be technical problems in trying to accommodate the very extreme cases, that is 100% of the population. So always the safe design in this case will be to have a range and accommodate the 100 population. Generally, designing for adjustable range is the preferred method of design, but of course it is not always possible. So this second principle, that is designing for adjustable range, is the most preferred among all these three principles. But it is not always possible that you can always design it by adjustable range. So based on the instances, you have to decide whether which among the three principles has to be used, but the most preferable method is adjustable range. Third design principle is designing for the average, and this one is the less common design principle. Why? Because the term average is a very subjective term. For example, if you look at this second point, that is, a person may be average on one or two body dimensions, but because there are no perfect correlation, it is virtually impossible to find anyone who is average on more than a few dimensions. So the term average may be true for few dimensions. For example, one person may be average in height and the shoulder length, but then some other dimensions may not be average. So always it is not possible to design for the average individual. But often designers, what they do is they design for the average as a cop-out, so that they do not have to deal with the complexity of the anthropometric data. So in order to avoid the complexity of this large amount of data, designers will have to sometimes consider this average concept. A thorough analysis of the situation may prove that average value is sometimes acceptable also. So there is no rule that average value shouldn't be used. It can be used, and sometimes it is also beneficial also. To the last slide, here there are some general suggestions how to use the anthropometric data. There are many suggestions, but I have limited myself to these 7 suggestions. You can have a look at all these suggestions. These are all self-explanatory, and these are all general suggestions.